10.6 Circles and Arcs. This whole first page is dealing with definitions of circles. The one thing I want you to do right now is I want you right up here to write out the word chicken nuggets. And the reason why is because tomorrow in class, when I ask you a question and I'm going to say, whose favorite something is chicken nuggets, I want you to raise your hand. That will indicate to me that you watched this video on time. So let's get into all these definitions. Actually, it might be a little bit easier once we actually start going over the problems, but when we have a circle, we have a center of a circle. So this is kind of review. When there's a circle, there's a center of the circle, just like how there's a center of a polygon. When you have a line that touches the edge of the circle, goes through the center and touches the other edge, that's the diameter. A radius starts at the middle and goes to the edge. That's your radius. A central angle is an angle whose vertex is at the center. So like this right here is a central angle. This right here, if I drew this right here, this is a central angle, meaning that vertex is at the center. So you know you have two congruent circles if you have the same radii. So that's just double radius. That's what radii is talking about. Circumference is the outside of a circle. Whee, just like that. And now we get into major arcs, minor arcs, and semicircles. So now when you're talking about a circle, we'll go off of this one. And let's say I have X, Y, and a Z. A minor arc would be less than 180. So like this arc right here is less than 180. A semicircle, actually I didn't even draw in a semicircle. So this would be a minor arc X, Y, and you draw a little arc over it. That's a minor arc. The semicircle would be either XW or WX. It doesn't matter. That would be a semicircle. Typically, though, when you're doing a semicircle, when it's 180 or if it's more than 180, you should have 3 points. So I should sneak a little Z guy in there so you know which semicircle I'm dealing with. This is a semi-arc, semicircle, semi-arc. And a major arc, same type of thing if I do XY, but if I said XZY, this is going in this direction because it has that right there is a major arc. So my minor arc would be XY. My major arc would be XZY. So this is just kind of some things that you might be able to guess. But when you're drawing a central angle, so like this angle right here, this angle is the same degrees as this arc. This angle degree is the same degree as the arc. Central angles and minor arcs are the same, and actually major arcs. So if I wanted to figure out what this is, and that's what this is saying right here, a full circle is 360. So if I wanted to figure out a major arc, I could do 360, subtract the smaller one. Let's get in some practice problems, shall we? So first, these problems should have had arcs all above them, but it's hard to draw arcs on the computer. So if I'm asking for arc TU, so from T to U, this arc right here is the same thing as the central angle. So that is going to be equal to 60 degrees. And I'm going to do RS, and then you're going to do the other two. So if I look from R, so my arc here, R to S, that would be the same as this angle right here. I don't have the angle. If I do have this straight line, that's 180, and I do have this angle measurement. So I could do 180, subtract 20, and that arc right there, R to S, would be 160. Again, that's a minor arc because it's less than 180. Pause the video and do B and C by yourself. For R, or SU, you should add 80, so you can add the 60 plus 20 because SU is the same thing as this angle measurement right here. And RST, that is a semicircle, so that's equal to 180 degrees. So here we have the formula for circumference. You can either use diameter times pi or 2 pi times diameter. Now looking at this first one, finding distance. Now if I were to draw a picture, it's saying right here that in a merry-go-round you have a seat here and you have a seat here. This first seat is 7 feet away, and this second seat is 10 feet away. It's asking how much further. So again, this is, make sure you're reading the question carefully. How much further does a child seated on the outside actually travel? So the first thing we have to do is figure out our circumference of both. So we want to figure out that length and I guess I didn't draw the circle the best, and this length. So here my radius is 7. So if my radius is equal to 7, again, going back to this formula, we can do 2 times pi times 7. That would be 14 pi. Or if my radius is 10, that'd be 2 times pi times 10, which would be 20 pi. It's asking how much further this person is traveling. So we take the larger one, so 20 pi, subtract 14 pi. This is kind of like the same thing as x's. We don't actually have the pi. There's 20, if I were to write these all out, 20 pi's here minus 14, leaving with 16 pi. You can also do that in your calculator. And I say 6 pi is the same thing as 18.8. And when I look at this, feet, because circumference is not squared. So that person on the outside gets a little bit longer of a ride there. Now we're going to go back to those arcs. So if I'm looking for arc length, so kind of like circumference, but that's the distance around the whole circle. If I just want a section of the circumference, so let's say just this arc right here. If I wanted to just have that portion of the arc, this right here is your whole circumference. Remember, you could either have pi times diameter or 2 pi times radius. And then you multiply that by whatever the arc length is, divide by 360, because that's our total. So we're looking for like the proportion or the ratio of this arc length compared to the total. So if I wanted to find just the arc length, now this is careful with the question. This is arc length, so that means I'm actually going to be using the units of C to D. So I'm looking at C to D. This arc degrees is 90 degrees. Now, if I wanted to figure out the whole circumference is this is my diameter, because it's right in the middle, diameter times pi. However, I only want C to D, so my arc length of C to D would be 90 over 360, because that's the proportion we want, times 9 pi. And if you put that in your calculator, you would get 7.0. I'm going to round to 7, and our units here are centimeters. Again, it's not squared because length is not squared. So right now, I want you to find the distance of S